Okay, good evening now. And I think it's a small group, so that's nice and cozy in a way. So we can introduce ourselves and then we can go into the session. I'm Indumati here, and I've been a science teacher educator and a science educator. And I've done research in the area of science learning and classrooms. So that's a little background about me. And today we'll focus on the nature of science. So I would invite if you can quickly share yourself, just a quick introduction from where you're coming, which school are you teaching in, and the subjects that you're teaching in. Some of you mentioned in the introduction that you're also working in as volunteers, or some of you are working in government schools as interns. So it's a nice mix of group here. So I would invite you to just quickly introduce, and so we can move on into the conversation. Yeah, Sindhu Mohan, would you like to?
Good evening, everyone. I am from Muscat. I am working in Indian school, Darsit. I am a science teacher for the last 13 years in this school.
Okay, thank you. And what do you teach, Sindhu?
Science.
All subjects, all.
I am in 3, 4, 5, classes 3, 4, 5.
Oh, okay. Thank you. Yeah. Can I invite Swapnil?
Am I visible?
No, you're not.
Yeah, but my video have his. Okay. Hi, this is Swapnil. I have recently started working. I stay in Rajmahendravaram, which is a city in Andhra Pradesh, India, and I'm teaching science to upper primary classes, like that is grade 4, 5, and 6.
Okay, thank you. Yeah.
Thank you.
Danya?
Yes. Hi, I'm Dhanya, and I'm right now in Bangalore, and I was teaching biology for grades 9, 10, 11, and 12.
Okay, thank you.
you.
So, yeah, Aparna.
Good evening, everyone. Aparna here from Delhi, Noida. I am a science and maths teacher at the PRT in Elcon Public School, Mayur Vihar. It is a 28th year of my teaching job.
Okay, thank you. Jasser?
Yes.
Good evening. Hello.
Yeah, please go ahead.
So I am Jasir here. Good evening, everyone. So I'm coming from Calicut, Kerala. So right now I'm teaching in grade 5 and 8 science and grade 9 physics. So I'm teaching in Andhra Pradesh, Vijayawada, in an international school.
Okay. Prashant?
Hi, this is Prashant, and I teach math and a little bit of science. I volunteer at a school near Bangalore. Yeah, that's pretty much it. Thank you.
Oh, thank you. So who else? Satya Prakash? Yeah.
Hi, I am Satprakash Singh from Lucknow.
And what do you teach? What subjects?
Yes, science and math and in organization Foundation for Advancement of Science in Lucknow in organization. I am giving my services there.
Okay, thank you. So yeah, Nishant. Hello, Nishant. Would you like to go?
Am I audible?
Yeah.
Yeah. So I'm Nishant. I just finished my undergrad in BSc undergrad, which is BSc B.Ed in Life Sciences a year back. So I work in an alternative setup near Hosur. So
Okay.
I teach sciences for upper primary.
Okay. And you completed from Azim Premji University by any chance?
Yes.
Okay. Navneeta.
Hi, I'm Navneeta here. Sorry, ma'am, I'm driving. I stopped the car somewhere. So
No.
I volunteer at a school near Bangalore. It's in the outskirts of Bangalore. And I'm volunteering there for the last 13 years. So I thought this program will help my teachers if I join and do something. So I want to learn more about science and how to take it forward in our school in a better.
Thank you. Yeah.
Thank you.
Kalyani.
Hello, good evening, everybody. Myself, Kalyani. I am co-founder of Milke Chalo Association in Jalgaon district of Maharashtra, and I teach science for 8th and 9th grade, and also I am project head of our science learning center. Yes, thank you.
Thank you. Kyle.
Hello, ma'am.
Yeah.
Sorry, I'm also out of home, so I couldn't able to connect my video.
No.
I'm Kaya here. I'm also working as a science teacher in Anjana Vidya Kendra School near rural Bangalore.
Okay.
Actually, I'm a newbie into teaching. Actually, I completed my PhD. Later on, I didn't have any contact with social life into any kind of teaching experience. So this is the first experience for me, and I'm so interested to join the course because it gives kind of new exposure into this field.
Okay.
Hope I will learn something from you.
Okay, welcome.
Thank you.
Yeah. I'm not sure. Mukesh, have you introduced yourself? Hello, Mukesh or Sindhu Mohan. I'm not sure if I called out. And anybody, if I missed out, please feel free to quickly introduce yourself.
Evening. My name is Aditya Bhatnagar, and I'm an engineer by profession. And I've been in education schools for the past 7-8 years. I'm a mentor at a private school in Chandigarh, and I mentor science teachers and also delve a little into mathematics. Both subjects I love, so that's my.
Okay, thank you. Yeah. Anybody else, if I had missed out, please. Okay, so I'll maybe quickly start. I mean, I'll share a screen, share a PPT, and we can get started. Okay. Yeah. So I hope you're able to see the questions here. I've put some questions to just start our thinking process, and then we can move ahead into the discussion. So what do you think of this one? Most scientists follow one research method and they do it step by step, do their research. Do you agree, disagree, or what is your view on this, please? Disagree. Okay. Aditya. Okay. Others also can please chat. I mean, type it in the chat box. Okay. Prashant has agreed to it, and Sindhu and okay, a lot of people have disagreed to this. That's interesting. You can even unmute and share. And I think one of you have said that you agree to it, right? Would you like to elaborate why you agree to it? Aparna said you agree to this, that scientists take, I mean, or a step-by-step approach, and there is only one method. Would you like to elaborate? And is there anyone who has said agreed? Prashant also has said that he agrees to this. would Satya Prakash, would anybody, one of you who has agreed to this, would you like to explain why you think they follow one research method?
It says most scientists follow one research method, so I'm sure there are other scientists who follow other research methods as but the way it's framed, right, to start with a hypothesis. So if you have a theory, let's say you want to try and experiment and try to find a theory, then the first thing you have to do is hypothesize. You have to figure out, okay, something's happening in front of me. Why is it happening? Right. So you hypothesize, and then to prove your hypothesis, you obviously have to design an experiment and see, if I do this over and over and over again, am I getting the same result or not? And if I do, then that's my data. Basically, I'm collecting data, following the hypothesis, and then I draw conclusions. And based on the conclusions, you can figure out whether or not your hypothesis is sound or not. So, I mean, that just sounds like a solid framework to me. I could be wrong, but yeah.
Okay. So others who have disagreed, would any of you like to share why you disagree, and is there any example?
For being agreed, one more thing added to Mr. Prasant's speech means dialogue reply, that it should be after being experimented so many times and collecting the data and drawing the conclusion, it will be means you can say acceptable by others. Yes, this is towards correct, means this is almost correct or something. That's why this design of research is okay, and that's why we agreed with that. Thank you.
Okay. So anybody who disagrees, why do you disagree?
I think scientists don't follow a very straight-jacketed approach as it is shown out here. You could start with data, and there are plenty of examples. For example, penicillin, there was no hypothesis at all, or even other things which have happened, Einstein's findings, and so on and so forth. So I think this is one of the frameworks that could be done, but most scientists won't follow such a rigid method. They might start with just doing an experiment and then finding out, okay, what's happening.
Right.
So
yeah. So I would also disagree with the statement for the same reason. Like if we take a lot of examples in biology, they are just observation based. Like theory of evolution itself is completely based on observation. Charles Darwin will not be able to set up any hypothesis or design an experiment, right? So so that's one way of doing research as well. And then there are, as Aditya sir pointed out, both Newton, Descartes, many of them, they're more theoretical in nature. They use mathematics as a way to prove their, and they didn't design some of the experiments. So the idea to point out here is that there is no one research method in science. Sometimes, and it's not linear also, that you always start with an hypothesis and then we design an experiment and then we collect data. Sometimes it could be another way around, or there have been a lot of coincidental or accidental discoveries as well in science. And there have been so there are multiple examples which we can draw from the history of science and say that science may not follow one research method. Yeah. So Prashant or Aparna, who said you agree, would you like to share more, or like does this clarify, or does this I'm not sure. Yeah.
It does clarify, yes. I mean, obviously there could be multiple ways of doing things. But yeah, I mean, this just sounded like a sound framework, so I was like, sure. But yeah.
Okay. No, the idea, often we tend to believe that there's one method in science. So the idea is also to question and say that, hey, looking at the history of science and how scientists have done over years, the idea is that to say and find out there is one method, or are there multiple methods. So the conclusion, or from the history of science, one can conclude and say that that's what scientists follow multiple methods. Yeah. So we'll move on to other questions. So scientists are influenced by their personal beliefs. What do you think? Is there a space in science, at least the pursuit of science, for personal beliefs? Okay, then yes, it strongly disagree. And Jasir also has like, I think it's Jasir who's there. It's strongly disagree. Okay, and agree. Okay, Aditya sir has said agree, and Swapnil also. Okay, Prem. Okay, would any of you like to comment? Strongly disagree. Like, why do you strongly disagree? That scientists are not, so you're saying that scientists are not influenced by their personal beliefs. Would any of you like to comment? Whoever said strongly disagree?
Ma'am,
Yeah.
so I feel, of course, the personal like knowledge, of course, it will affect, but personal belief is something different, right? So belief could be like, I feel it's more like influenced by the society and other socialization and all. So belief should not affect science, but maybe personal knowledge, but scientific knowledge. So I think that is a different strata, and personal belief is something different. So I feel personal belief should not influence science, but the scientific knowledge a person hold, the scientist hold, that can influence, but I feel not personal belief.
Okay.
Yes.
Somebody who's agreed, can you please elaborate? Kyle or Swapnil, that some of you have said that, yes, scientists definitely are influenced by their personal beliefs.
Hello, ma'am. Like,
Yeah.
it's like belief here. We are not talking about spirituality or other things, but we know a lot of scientists who believed on what is the truth and they have tried to explore. Like, we know about Leonardo. He believed in a lot of things and he continued working. Like, he even worked on corpses, which was not allowed to touch. We know that Galileo and others, they went against the general beliefs of the society because they believed in something. So it's,
Yeah.
I think they are not bound by like belief. It's here what they believe, they continued working for the same.
Oh, that way you're saying. Okay. What here we meant is like their own personal experiences or their presumptions. Do you think those influences scientists when they do science? Anybody?
I
Yeah.
feel it will influence little bit because based on my personal beliefs and values, maybe whatever objectives I choose or the research choices or how I want to interpret the data or even the questions they I wanted to choose to investigate also, it affects.
Definitely.
So it basically I cannot tell completely into that, but it affects.
Yeah.
So I agree with it.
Okay. Okay. Thanks, Kyle.
Thank
I
you.
also agree because I thought that when you're talking about personal belief, it means that whatever the person, his background or his beliefs, the way he's been brought up, and that strongly, I would say, influences the way that a hypothesis is generated, because that's a creative process.
Yes.
The process, the remaining process of thing, they may not be, and one would hope, or a scientist should not be influenced, but I don't think it's practically possible.
Right.
That's what I think.
Yeah. So I would, somebody wants to add? Sorry.
Yeah. So I'm not sure about the scientific how the history. I cannot comment on the history of science. Comment from the history of science, but taking the perspective of education, when you think of how any human works, when you encounter with some question, your mind is obviously, I feel like it's going to think about your previous experience and then you're going to come from there.
Right.
I think Piaget talks about that.
Exactly.
Yeah.
Yes. And science is a human endeavor, and we are located in a social, political, whatever context we are from, and we have our own previous background, understanding, experiences, all of that, our societal, whatever. So all of this, I would say, or again, the philosophers and the historians of science would say that yes, scientists are influenced by their personal beliefs, and you cannot keep them away and out. They're not neutral people. Like even as Kyle pointed out, even the question that you choose to research, so that's where is it coming from? And as Nishant also said, and Aditya also pointed out, in the reading as well, if you've gone through the module 1 and module 2, the idea that is discussed is that scientists are influenced by their beliefs and experiences, their previous ideas and notions, because you cannot isolate them, right? They are in the context, they are in the society, they are within the socio-economic political context. So all of that definitely influences what they do as research, the kind of questions that they pick, the hypotheses that may come up with, or even observations that they may make, and then from there draw conclusion. So all of these processes that they do could be influenced by their personal belief is the idea. So if some of you disagree, maybe we can have a little bit of more discussion on this, because it's not an easy idea to accept quickly in a like a presentation. So if you want to dwell more, or no, you still think that they don't that you don't agree with this, you're welcome to add and
I still feel I don't agree with it.
Okay.
Maybe the scientists' research interest might be based on their experiences or beliefs or what they like or they don't like. But their experimentation and the analysis of their results and conclusions might not be biased, is what I feel. And even if it is biased, science as a process is sort of peer reviewed. There are lots of people also reviewing every scientist's work. So that kind of bias based on one's own experiences and presumptions will quickly be ruled out, is what I feel.
Okay. Does anyone have anything to add to Danya's what she said? Can some of you think of an example where you think, yeah?
Yes, so I just wanted to, in a way, try to give an example.
Sure.
If you remember Einstein's, theory of relativity, which he published, I think, in 1905, that took a long time for people to accept, for the simple reason that they were already having that personal belief that this can't be. You can't have, time being relative, for instance, or length or distance being relative. So it was a big paradigm shift for people.
Yes.
Kind of accept. And very eminent physicists, I don't remember the name, but I think very eminent physicists in Germany for about 20 years contested strongly, Einstein.
Okay. Yeah. So I would also agree with what Aditya has shared. Definitely there is, people, I would come from this argument that scientists are people who are located, who are in the socio-political context, and we cannot keep that out when we're doing research. Also, the kind of funding that one gets, how the government. Yeah, sorry.
Okay, no, that's fine.
Yeah, okay. So that's what. So to add to your view, so scientists are located in the context, right? And they bring in their own personal context. Like, for example, from what I know, Charles Darwin's theory was influenced by Malthus' idea, the economic, whatever Malthus proposed as a theory during that time. And what Malthus presented was that there is, only when there is competition, there is quality, or only when there is competition, there is survival, or people compete and then they reach the whatever. So that's what the economic theory was around that time. And during Industrial Revolution, and when Charles Darwin also proposed it, he was in a way informed by the theory already. So his theory also kind of was in that framework. And Charles Darwin also said that there is competition and then survival of the fittest, all of that, right? So we are influenced by the context that we are in. like as you pointed out. That's what, and as Aditya pointed out, really we are in paradigms, we are in worldviews, isn't it? For a long time, I mean, we didn't believe. I mean, the heliocentric model was never accepted. The church was against it, right? And the geocentric model was prevalent for at least, I mean, many centuries. So when Galileo presented it, or when kind of Kepler or anybody kind of shared that view around that time, many people were opposing it. So all these context influences our research. Yeah, Kyle, yes, would
Yes,
like to
ma'am.
add? Yeah.
To keep as a simple example, I wanted to quote like, suppose in a classroom experience, if I want to find the impact of some new education program, I wanted to frame a new program to see the effectiveness of that program on my students, maybe. So it obviously depends on my personal belief. I will, whatever experience I gathered, or what I think inside myself, or what I have gone through, with that belief only I may get little bit influenced, and I will start to frame one program, and I will start that program in my I will implement that. Whereas for other person it may be different, based on their personal experience, or their objective, or what questions arise in their mind. They may think that technology may improve their program. So what I believe and their beliefs, it influencing the program. Same program, we wanted to find that program is impacting or influencing the maybe the educational status of the kids. But my personal belief and experience, it's influencing the same program, whereas the other person perception is different. It's a simple what I'm saying. Maybe the question what arising inside us, that simple thing also may influence the.
Definitely. So, see, from your example, that is more social science research or research in education, right? Definitely there, very clearly, yes, it is from our personal and social context and all of that. But here, when we're talking about scientists doing research, like at least if we agree that scientists are people who look at natural world, and there are others who studies education or any other society or anything, they are all different, right? There may be social scientists, they are
true.
So that distinction I want to draw here. So here we are talking about scientists when they are doing their research. So people who are studying the natural world, can they bring their personal beliefs? So I would say yes, they do bring their personal beliefs.
Still, their personal experience will influence, no, ma'am?
Definitely, yes, that's what. Yeah.
So, for example, if I feel like drumstick leaves are rich in iron, where I come to know from my parents or from something which I already know from my normal regular life.
Right. Yeah.
From that, I start my investigation or some research on that.
Yeah, probably. Yes. Yeah, right. And that's what, even our cultural context, all of it, like our food habits, like we might believe that curcumin, turmeric, eating turmeric, like as you're saying, similar example. There is value in it. And so then you're interested maybe in that area, and you want to prove what it actually contains and what it actually, what are the chemical components in it and why is it beneficial. So that's what, so all our practices, cultural practices, our economic context, our socio-political context in the place or the wherever we are living in, all of that I would say definitely influences anybody. And why I would say it in a very clear conviction is that also because science is a human endeavor. We are doing science, right? Scientists are not anybody who are out there. They are people like us. So, and for anybody, normal people, it's normal to have a lot of beliefs and all of that. So I think we'll move on to the next one. Yeah. Okay. Research in science is deductive. What do you think? Do we all understand the distinction between deductive and inductive research? If somebody is very clear, maybe can add or share to others in the group what is inductive or deductive research. Okay, so maybe to move ahead, research is of different paradigms, right? Either there is a deductive logic or there is an inductive logic. Okay. And deductive logic is when often used in mathematics, like when you say that A is equal to B or B is equal to C, and then so therefore A is equal to C. So you deduce from the statements that you propose, right? Whereas inductive is from the general observations, the observations that we make, from there drawing a generalization or a conclusion. That is inductive. Like for example, at least in biology and lot of other sciences, what happens is that research is often more inductive. Like for example, let's take an example of aspirin or any paracetamol or anything. How is it tested? This tested saying that okay, it works on some say 10,000 people, and hence aspirin is a very good medicine or very good treatment for cure for headache or fever or whatever it is. So that is the induction. Yeah. So when we draw from the conclusion, we observe, and then we make a lot of observations. We also set up experiments, and then maybe have a control and a variable, and then we make a lot of observations, and from the data we make a generalization. So that is inductive. Yeah. So in a way, according to my understanding and what nature of science also indicates is that science is very inductive in nature, except for theoretical ideas, especially theoretical physics, or any research that uses mathematics, for example, could be more deductive. But whereas lot of sciences are inductive in nature, it is based on that assumption. There is an assumption that okay, it has worked 100 times, and hence it will work on the 101th time, like vaccine research or even genetic modified foods, all of that. Like when we say that genetic modified food works, or it is a beneficial kind of a crop, or it is a beneficial way of growing whatever the thing, and then we test it, and then we find that yes, it is effective, and it has all the nutrients that the original the plant that has. So all of that, if we conclude, and then we assume that okay, so genetically modified whatever another plant is also good. That's how we come to a conclusion, right, in science. So science research is mostly inductive, though we might assume that science follows the A to B and hence B to C kind of a thing, but often sciences are inductive in nature. Yeah. So what approach would you call finding molecular structures like DNA or ribosomes? Um, okay, this is making me think. That's an interesting question. Yeah, what approach would you call finding a molecular structure? Okay, so they have, say, anybody with Watson and Crick and others, or Rosalind Franklin, who were contributed to it, they were trying to understand the molecular structure, right, through X-ray studies and various studies. And then they came up with an general conclusion saying that it is it's making me think. What do you think, Aditya?
I'm not really clear because the fact is that as far as DNA, let's say if we talk about DNA, which is quite well known, they took a lot of data from crystallography. So they did a lot of
right.
crystallography, and from that data they tried to make a model.
Right.
But they also deduced that how the double helix should be. That was, so I don't know whether some of it is a mixture of inductive and deductive.
Possible. Yeah, right, yeah. So I'll also read up a little bit on that. That's an interesting question to think about. As you're saying, it could involve both inductive and deductive kind of logic while doing that. Yeah. Okay, so we'll move to the next one for the paucity of time. Okay, sociocultural values. I think we touched on it, so we can move ahead. Like we did while talking about the context of scientists. We just discussed that scientists, whether they bring in their personal beliefs or not. So we also discussed that sociocultural values do influence scientific investigations. So we'll maybe quickly move and okay, scientists are value free and they remain objective. What do you think? This in a way also implies from the previous um kind of discussion. I think we pointed out or discussed somewhere that science is not really value free, and it is difficult for scientists to be really objective in that sense, because everything is defined by the environment that we live in, right? There's context that we live in, and scientists also live in the context. So though they may be, they may like mathematical, at least theoretical physics, and some of it may be deductive and objective in nature, but again, scientists may not be really object, and it is not really possible to be neutral and to be objective all the time. That is my kind of view. Does anyone have any questions? Disagree? Okay. Does anyone agree to this and then still find this problematic? Okay, Kyle has said that you agree to this.
Sorry, ma'am, I actually posted the answer for the before question.
Okay, okay, fine, fine, okay. For some of you, I'm sure this is maybe like a starting point, and you may really disagree with a lot of the statements, or you may be on the other side. But I would definitely encourage you to read the texts that are both there in the the module 1 and the module 2. Okay, and we'll move on. So scientific truth is relative. What do you think? When we say scientific truth is relative, is it possible? Yeah, you think it is relative? You mentioned about paradigms, isn't it? Paradigm is a very good example, or a worldview, right? Einstein's paradigm. So everybody operates within Einstein's paradigm now. Whatever is now relevant is relative to that paradigm, isn't it? Like, for example, the heliocentric and the geocentric model itself, the move from that. So when we started at that time, it was, most of the scientists also believed, or people believed, that the Earth is flat and Earth is at the center, right? And then after at least 200 years is when okay, we were able to prove that the sun is at the center and Earth is not flat. So any research that happens during that time, so all scientists would work in that paradigm, right? So if for a long time Newton was a paradigm, Newton's laws of motion was a paradigm, or that was a theory that was prevailing. So all the research that would happen uh, considering Newton's ideas, would draw or adapt and then work on that, right? So that is why we can say that truth is relative. Scientific truth is also relative. It is relative to that paradigm. Yeah, it is true until a new research comes out. Yes, Jasdeep, yeah. Not always. Okay, Prashant has said not always. Okay. Okay. If you have come across Thomas Kuhn, yeah, okay. He's a philosopher of science, and he proposed an idea that saying structure of scientific revolutions. Okay. And he is the key proponent of some of these ideas. He said that science is relative. Okay. And scientific knowledge is tentative. And so maybe I'll quickly take you through that, the structure of scientific revolutions very quickly. So this is Thomas Kuhn, who is a philosopher of science, and he proposed that science is paradigmatic. That means it's a worldview at one point. Like, for example, there is some science, there is normal science. Say, let's take Newton itself as an example. So Newton's theory works. He has proved it. Others also confirm to it. Okay, and then that theory is established, so that is okay. And then slowly they find some anomalies. Okay, maybe one or two, very one or two anomalies, and then they think, okay, that can be retested, it can be modified a little bit, and all of that. And then what happens? The anomalies start growing. There are more and more, and some explanations are not possible at all using Newton's idea. So then there is a crisis. Like there is a need to have a new theory, right? So Newton was not able to explain heavy objects movement at very high speed, especially planets, movement of stars, and all of that. He was not able to explain. Similarly, subatomic particles, Newton's law cannot explain the movement of subatomic particles and all of that, right? So slowly the crisis kind of anomalies start adding up and more, and then there is a crisis, and then there is a need for another view. There is a need that comes up for a change in the view. So then there is a change in the worldview, and then there is a initially there is some proposal, some one or two scientists come together and then they propose, and then they say maybe there is a possible explanation and all of that, and that is tested by multiple people. It is confirmed, and then a new paradigm kind of evolves, right? So the entire idea of nature of science that we are drawing in both the modules that we have put up as articles draws from Thomas Kuhn's Structure of Scientific Revolutions. Yeah. And it says, or it in a way points out that science is paradigmatic. That means we move from one worldview to another worldview, and truth is relative to that worldview. Like if for a long time we believe in geocentric model, yes, most of the scientists would work on that model, and then there is a shift towards the heliocentric model, and then scientists start working using that model. So they build on, add on. So there is Newton and Descartes who propose some laws of motion. So they work on that laws of motion, they adapt, test it, verify it, do experiments, and slowly they start finding anomalies, and then there is a need for a new theory to explain certain motion and movement. So that is how science evolves, according to Thomas Kuhn. Yeah. So how does it, what is the need of discussing this in the classroom? What is it for science classrooms? Why do you think this has any role to play in a science classroom or in teaching learning science? Whatever we discussed about the history of science or the philosophy of science, what do you think is, how do you think is useful for classrooms and for teaching learning? Do we need to know as learners or also as teachers, do we need to teach and know some of these ideas about history and philosophy of science? And how do you think it can inform our practice in the classroom?
Definitely, it will help children.
How?
Because they should question, right?
Yeah,
Whatever
yeah.
we say, they should not believe and just move on. So
Okay.
that is be the first point to think about
Okay,
the
okay, great.
classroom situation.
Okay. Uh, so talking about history and philosophy of science, yeah, right. Aditya also has pointed out that students should understand how science happens. Yes, definitely. And that does not give absolute declarations. Yes, science is tentative and science is not authoritarian. Yeah, very valuable. Yes. So often there are these common misconceptions, right? Or that we carry, right, about scientists and scientific practice itself, right? And often science is used as a very superior kind of a knowledge, and often in our common parlance we tend to say this is scientific, and we tend to use science as the way to prove or disprove anything, right? So but that is not the case, isn't it? I mean, from the history of science, from knowing from the philosophy of science, we know that science is not absolute and it is tentative, and scientists also are it's a human endeavor, it's a collective endeavor, and we operate in the context. And when we look at the history of science, when we read the history of science, there are a lot of interesting that comes up, like how scientists have collaborated or not collaborated or whatever it is, and then how they have failed in multiple experiments, and their own not only experiments, anything, and how certain scientists' work are made invisible, they're not available, right? And some scientists have been very powerful, and even that's what. So Indian science itself, we can take that as an idea. All female scientists, where are female scientists, right? So why are they invisible? Or was it not available? Was access difficult to them? So we can go into such questions, like especially with the DNA question, right? Watson and Crick were awarded the Nobel Prize, but whereas Rosalind Franklin made a very important contribution and she was not recognized for a long, long time, almost for 80 years, something like that. When she was 80 or 90 is when her work was recognized, and then they said, okay, maybe the Nobel has to be shared with her, and I think by then she was dead or something. I'm not very sure of that complete story. But then, so these are all these, there are this stories of scientists, their practices also. How have they done research? What has led to them? What has led to their discovery? Who else contributed? What was the universe, their space is like? And is it Western? Is it located in the Western context? Or are there, again, just today or yesterday, I came across Upendranath. He is a scientist and who developed a vaccine for Kala Azar, I think. Vaccine, or I'm not sure, a cure for Kala Azar. But he was not recognized at all. He's a Bengali, and now I'm not sure. So his work was not recognized. So similarly, that's what, there are a lot of scientists who have done work and they are invisible, they're made invisible sometimes. There are some who have interesting ideas, but they were not able to come to the forefront. All of these stories are also there. And at the same time, how did scientists go with this pursuit of science? Like, how did they make these observations, and what constraints and what limitations? So all of this, yeah, right. Thanks, Aparna. Yes. To say that science also evolved gradually and through failures and whatever, and we have adapted, scientists have adapted and used ideas from one, and then they have improved on the other. So things like that. So we need to place science in a context and bring in history of science. History of science is a very valuable teaching, learning pedagogy. It's a great tool, and through history of science we can say bring some of these aspects of nature of science. So who are these scientists? We can discuss those ideas as well when we bring in the history of science. So yeah, quickly, that is what I want to share and conclude here. If you have any questions, any of you, we can discuss, and if you would like to share some of your experiences of using history and philosophy of science in classroom, I would invite you to share that and do that. Yeah, anybody who has tried or used history of science? Yeah, please.
I want to know about this ethno science. There is like ethno mathematics.
IGNU? I didn't get.
Ethno science.
Hypnos.
Like ethno mathematics.
Hypno science, you mean? Hypnotism? Yes. I'm not getting.
Okay, ma'am.
Ethno science, I think, is right.
Ethnoscience?
Yeah.
Oh, okay. Thank you. So that's what ethnoscience is, saying that science also has to be culturally rooted. That we have to, bring about the cultural context and the science that is specific to that culture. Maybe that is what is ethnoscience and ethnomathematics is all about. Drawing from people's culture, like for example, Arabic or India or Chinese or wherever that is located, drawing from our practices, from our cultural practices. That's a very, it's a very, what to say that, that's what, all of this has an influence on sciences, and there is a valuable knowledge maybe, and Western science is not the only science per se. What we use or what we have now is modern Western science that we have, but there are indigenous local practices and cultural practices that are also equally valuable. Maybe is it possible to do research on that? That's ethno-science and ethno-mathematics. Yeah.
I can share one experience, from my classroom.
Sure.
So this is for grade 7. They are studying heat.
Okay.
And we told them that, look, one of the theories of heat was called the caloric theory of heat, which was, developed by Lavoisier. And it was in prevalence for about for almost 200 years. And the thing he proposed was that heat is a fluid and it flows from higher temperature body to a lower temperature. Now, they were asked to find out ways and means in a physics lab, use whatever physics lab thing, whatever they wanted to use, and try to find out ways and means by which you can either prove or disprove this. And you have to first say that you agree with the theory or you don't agree with the theory. So it was interesting, but there was, I would say, just about 25 to 30% of the students. I mean, all sections about 120 students, about 25-30% who really delved deep enough into it. A lot of them tried to do the conduction experiment, where you put pins on a rod and you heat one end and it try to see that. So they were trying to go that route. Some people try to measure the weight, that if you heat it, does the weight go up, and so on and so forth. So, but they appreciated that this belief like this stuck around for 200 years. And a handful of them discovered that the way it was disproved was not by a scientist, but by somebody who was making a cannon, who makes cannons. And for making cannons, they had to bore the brass piece, and he found that it was getting hot. So if it was liquid, where was it liquid coming? Is it being generated? Where is it coming from? And in fact, that whole idea that friction creates heat as well sort of sounded the death knell for this theory. So that's how it works.
Yeah, interesting. Yeah, definitely useful. Yes. So I also tried once teaching using history of photosynthesis to talk about how also while teaching photosynthesis, another important thing that happens is respiration is taught separately and photosynthesis is taught separately. Respiration in plants and photosynthesis plants are taught us two different topics or chapters, but they are very well interconnected, right? Plants do respire and they do it at the same time. And there is a common misconception among students that often, even in science textbooks, the way it is represented as a simple equation, that oxygen is given out and then carbon dioxide is taken in. So always there is an assumption that carbon dioxide is taken in and then oxygen is given out. But it is a process other ways in respiration, right? So when I use the history of science to say that how oxygen itself was discovered and how slowly scientists started finding out about the role of carbon dioxide, and then slowly they moved to talk about how photosynthesis as a process, there is the presence of chlorophyll and all of that. How did they find? So when I used that, it made kind of some sense at least, but it took a lot of time, of course, yes. But then we also tried some of those experiments, weighing the soil, is there a difference? And then if we weigh the soil and then leave it for without watering the plants for some whatever days, does it change? So all of that, whatever we scientists tried to do, we also tried to replicate some of them, whatever was feasible. And then we also saw that yes, there is it's a worthwhile process, it's a worthwhile thing to do, to go through that similar process of how scientists might have struggled with this question, and things do not work in isolation, and many ideas come together, they go together to understand that concept. Photosynthesis is just one idea, but to understand photosynthesis one need to know the role of carbon dioxide, the role of oxygen, so all of that, right? So yeah, that's maybe a way. So there are a lot of interesting Isaac Asimov, if you have come across him. Isaac Asimov, author, he has published a lot of little history of sciences. He has published on history of electricity, history of photosynthesis, many chapters like that. And it's very interesting and it's available online also. So maybe I can quickly put it up here. ArvindGuptaToys.com. If you've come across ArvindGuptaToys.com, let me Google and put it here. And Jasir, can you please elaborate your question when you have said this?
Ma'am, it was not a question. I was saying that like if any sort of new theory or any new finding comes right now, maybe the society may not accept that soon. So if we look back in the history, we can see that very easily, like how much time for different principles it have taken time to accept in that way, I was saying.
Right. Yes. Yes. Yeah. It also shares that's what has been the time that has been taken, and how many of them really collaborated and contributed to that idea. It may not be just one person. Often we study Michael Faraday did this, or Lavoisier did this, or somebody contributed to this, but it's not as simple as that. There have been multiple people who have actually made a interesting idea. In fact, even Galileo's ideas was based on Copernicus. Then Kepler also kind of contributed together, right? But we often attribute to one person, maybe whoever is very popular or whatever happened around that time. So that's another thing that happens with the history of science. We know that there have been multiple people. Many of them have failed, and they started with one question, and then maybe it led to another question. So that also we know, get to understand. Yeah. So this is the website I was just mentioning. I'm sure many of you would have used it. In this, there are a lot of interesting Isaac Asimov resources. There are other interesting resources also, which here on the history of science, there are a lot of interesting, like 10 pages kind of snippets on how certain concepts developed, certain ideas developed in science. Maybe you want to have a look at it. Yeah. So if there are no more questions, comments, we can move to uh, uh, any other questions on the structure of the course or assignments or anything of that sort. Of, we can quickly move into that. Often this one-hour webinars, often there is paucity of time. So yeah, if
good evening, ma'am.
Yeah.
Ma'am, actually, I am a student right now. I was teaching in a school, but now I am doing my master's with my research.
Okay.
So I joined for the course, and actually, the first week of January was pretty hectic. I was not able to attend the modules which are uploaded. So will they be active for the coming weeks? Like, can I complete my course and still get the certificate?
Oh, definitely. Yes, yes. You can access it till February 18th. Yeah.
Okay.
So it will all be available. All the modules will be available till the end of the course. And even after the course, it will be available. But to, complete the course, you need to submit all the assignments on time.
Okay, so after completing the modules and after completing the assignments, we'll get the certificate then.
Yes, yes.
Okay, thank you so much, ma'am.
Yeah, right. So any other score specific questions, assignments, we can spend like 5 minutes on that. Or if you don't have.
Excuse me, ma'am, what are the assignments? I couldn't find.
The practice assignments, there are 2 of them which are already, I think it is open. Yeah. It is open. Already I have made it available to you. In the course, if you go down to the end, there are assignments, and then there is practice-based assignment, and then there is another assignment 2, which is part B. Yeah. So both these assignments are like you have to try something in your classroom and then maybe share your experiences of that sort. So it will be useful if you could take a look at the assignments, and then if you have pertinent questions or how to go about all of that, we can discuss in the next webinar also. So I think the multiple choice questions are already there. That I think goes along with the course, and then you'll be able to do that as you complete the modules. But these assignments are practice-based assignments, in the sense one of them is about recording your practice and then analyzing it. One of them is there are choices as well. One of the assignment is about analyzing textbook, analyzing modules, clicks modules that are available. And one of the assignment is also to develop an inquiry-based lesson, and then teach it for few students, and then share with us the experiences. So there are choices in all the assignments. So there are 2 of them.
May I?
Yeah, yeah.
Actually, what is there, what is available there as activity 1, 2, and etc. All those I just covered few days back. But if you are talking about something else, assignment in the name of assignments, then can you please share the link so that I can be sure, I could be sure that what I did, it is the same you are talking about.
I can maybe share my screen and show it to you. There is an assignment section at the end of the.
I did some questionnaire and.
No, not the MCQs. We are not talking about MCQs.
Okay.
Yeah, this is the course structure, right? This is the course that you might have, right?
Yes, this one I did.
No, no. What I'm saying is course progress dates or discussion, all of that. And you would have all the modules here listed, unit 1, unit 2. As of now, only unit 1 and unit 2 are open, right? And then
Yes.
you go down, there is an assignment here.
Okay.
So in that, there are 2 of them that is listed, assignment part A and assignment part B. So these are the assignments that I'm talking about.
Okay, that unit 1, unit 2, I just opened and I did all the MCQs and something was there, watching the video and all. But these, and one I opened where it was written to, where we have to just submit the video or something of our class of 20 minutes and all. That is in my knowledge. If these assignments are other than those, then where could I just see?
No, you please, that's what you are referring to is right. One of them is about taking a video of the class and then analyzing
video
it.
of 20 minutes video and something like this. Okay,
Yes,
okay.
Yes. Yeah, that is the one.
Yeah,
That is.
thank you. Actually, I'm trying to participate in that also, what is given through school for Tata School Edge of 40 minutes video. So
okay,
that is different from this. Okay, thank you. Got it.
Yeah, okay.
Ma'am, can you excuse me, ma'am?
Yeah.
Ma'am, can you please suggest me some way for this 20-minute student recording video, because now I am doing my master's, so it's
No, there's a choice here in this assignment. So if you go through it carefully, either you could record and upload, or there is a inquiry based lesson that you can prepare. And then, so there are options in all the assignments. Yeah.
Okay, thank you, ma'am.
Yeah, sure. But then that assignment you could teach for at least 5 to 6 students, for whomever you develop that lesson, part of the lesson at least
Yes,
30 to 40 minutes class.
Okay, ma'am, sure.
Excuse me, ma'am.
Yeah.
Ma'am, do we need to upload the video also, or only the write-up?
Only the write-up.
Okay, and one more doubt, ma'am, that write-up only should be analysis based or dialogue based. Like we have to only draw an analysis out of it, or we have to write the student responses also in a dialogue way or something.
No need to write students dialogue and all of that. What did you draw from that? Your own analysis of your classroom.
Like, ma'am, actually in the assignment B, there is a suggestive link given where we can go through how to write an article. But no such supportive link is given in the assignment 1. Will it be possible to provide something? Then we'll get a better idea how to frame our article.
I'll check and see if there is any. So you're saying assignment A has a
assignment
link?
B has a supportive link, ma'am.
Okay, here. Maybe. Let
Ma'am,
me
second
check.
assignment. This is the first assignment. In the second assignment.
Okay.
Second assignment where we have to analyze the textbook. There a supportive
there is
link.
Yes, I got it.
An idea how. But for part A, nothing of that sort is available.
Okay, got
If
it.
not detailed, at least a part of it, if we will get a better idea how to frame our analysis.
Here is a request.
Just a request if it is possible.
Here is a request. If possible, can we have a WhatsApp group? Then our queries can be solved there easily.
I'm not sure. See, the discussion forum, you can use the discussion forum extensively, and I'll definitely reply to it within a day, or at least in 2 days. That can be done. The WhatsApp group, the problem with that, I can check with this team. The thing, what happens is that there are multiple groups. We run courses simultaneously. There are multiple courses that happen simultaneously. So then it becomes very difficult for us to handle some of them, respond to many queries that comes up there. So discussion forum makes it easier. I'm sure, I mean, my contact email, I can give my contact email, definitely. I'll type it here. That also you can use to reach out to me. Yeah. Clicks India.
Excuse me, ma'am, one more
Yes.
small doubt.
Huh?
Ma'am, actually, like in chapter 2 also, like part 2 also, we have been asked to write about history of science, choosing one topic and write an article. So that we can as such post in the discussion forum, or it should be in PDF or Word format, anything like that?
No. Those, whatever is there in the discussion forum, you need not write a PDF or anything. You need not submit a Word doc or a PDF. You can just paste it there.
Okay. Thank you, ma'am.
Sorry. Yeah. This is the right one. At clicksindia.org. So this is my email ID. If I don't respond in the discussion forum, definitely I'll respond over email. You can message me. And the other thing is, and another request to many of you or all of you is that in the discussion forum, please respond to each other's questions, queries, suggestions also. That will make it even more interactive. And a lot of you, I'm sure, have a lot of experience from your own classrooms. So it will add great value to if you do that. Yeah. So I would request that all of you please ask questions to each other. If somebody has posted something or suggested a link or whatever it is, if you have questions, please do post, and so that make the discussion forum very active, and that will be useful. All of you are, as of now, some of you have posted your own respective materials or respective views and all of that. But if you can even comment on each other's responses, that will be great. So we'll have one more webinar at the end of the session, around the last week. I mean, the last week of the 5th week of the course or something like that. So you can clarify anything further. And we don't have much more questions. We can maybe sign off, and yeah, we can end this webinar.
Oh, thank you, ma'am.
Yeah, you're welcome. Yeah. Yeah, thank you,
Thank you,
everyone.
ma'am.
Thank you
Yeah,
so much.
welcome.
Thank you.
Yeah, welcome. Yeah. Thanks. Good night. And thanks for participating at this hour.
Thank you, ma'am.
Yeah, you're welcome. Bye.